Good afternoon. Welcome. What I'm going to talk about is Java, current state of Java, and the future of Java. And what I want to do is to start by asking you, the audience, 3 questions. So the first question is, who here is using JDK 8? Ah. Interesting. Okay. Anybody using anything older than JDK 8 in production? Okay, a few hands. That's fair. Okay. Anybody using anything newer than JDK 8 in production? Okay, few hands, but not many. Okay. Good to know. That's kind of what I normally see when I ask those questions at the moment. So what I'm going to talk about is how Java is changing at the moment. And I'm going to do that both from a technical perspective, but also from the point of view of how the delivery and the development of Java is changing and has changed. So let's start with JDK 9, because that came out just over a year ago. And I borrowed this slide from Oracle. I used to work for Oracle, so I figure I can borrow some of their slides. And it lists all of the features that went into JDK 9. And if you ask Oracle, they will say that this was the last big release of Java. There are about 86 features there, and many of them are quite small, they're quite low level, and they are ones which developers don't tend to see too much. But there are some there which are quite significant. And really, one of them is very significant, and that is modularity. So I don't want to spend too long talking about modularity because, it's been around for a while, but there's a couple of things that we do need to make sure that everybody understands about, and then we can talk more about what's happening in the future. So what did modularity really do for us? Well, the first thing is that it broke up the core libraries that we have into a set of modules. Looking at the history of Java, if you go back to JDK 1.0, there were 211 classes in the core libraries. So that was okay, great, you could use those for developing code. Move forward to JDK 8, which most of you are using, and you will find that the rt.jar file has 4,500 public classes. This is really good because it means we don't have to write our own semaphore class. It means we don't have to write our own array list class anymore. All of these things are provided for us. So there's a much richer set of APIs. But the drawback with that is it's become very monolithic. So all of these libraries are in one file. In fact, 2 files, really, because it was rt.jar and tools.jar. So the idea behind modularity was to separate that up into more manageable, more logical pieces. If you think about what we had already, we had classes, and we could group classes into packages. Modules is about taking packages and grouping those together logically. What we ended up with, if you look at the OpenJDK, is 75 modules. Of those, there are 27 which make up java.se. This is the standard that's defined through the Java community process, through individual Java specification requests, and it's what you need in order for something to be Java. So it's the minimum that you can have. But then there are a whole set of other modules on top of that. There are 48 which are JDK-specific modules. This covers all sorts of different things. It covers things like the tools that you get. It covers things like Nashorn, the JavaScript engine interface, things like that. If you look at the Oracle JDK, there are some extra things. So there's another 14 JDK-specific ones. There are 8 modules for JavaFX and a couple that are even Oracle-specific. So that's all good. They break up the module, or break up the rt.jar into manageable modules. But the other thing that the designers of the modularity system did, and this is the thing that has much more impact when we're migrating applications from JDK 8 or earlier to JDK 9 or later, is the concept of encapsulating internal APIs. If you look at rt.jar, 4,500 public APIs, but there's a lot of classes in there as well which are not intended to be used by the average developer. They're there to make the public APIs work. Now, the most famous or infamous of these is sun, misc, unsafe. I really like unsafe. The clue is in the name. Unsafe. don't use it. So let me ask you another question. Who here has used sun-misc unsafe functionality in their code? Okay, a few people, but not too many. That's good. Okay, let me ask you, who here has used a third-party framework or library, like Spring or Log4j or anything like that? Yes, there you go. So you have used sun-misc unsafe, you just don't know about it. And what the developers of Java wanted to do was simply say, okay, we never wanted you to use these APIs. We have always said that we're not going to document them, we're not going to explain them to you, so we don't want you to use them. And the idea in JDK 9 was to simply say, right, we'll cut off access to those. We'll encapsulate them, make them invisible. That wasn't going to work, because, as we see, many people have used libraries or frameworks that use this functionality. There's a very good reason for that, because sun-misc unsafe gives you access to things which are very useful for writing frameworks and libraries. So the developers had to kind of go back a bit and say, right, okay, we're not going to cut off access completely, but we'll give you some command line options, some flags, which you can use to gain access to specific things. So there are things like that that you need to consider when you're moving to JDK 9 or later. Now, the other thing with modularity was it changes the idea of the Java runtime. In the past, we've had the idea of a JDK and a JRE. The JRE being a subset of the JDK, which you can install on machines where you're not developing code, but you simply want to run a Java application. It was smaller, it meant you needed less space. That's gone away. Now the idea is to build a runtime which is specific to your application. We have modules. It's broken up rt.jar into manageable pieces. So why not just include the modules you need for your application rather than all of them? And that's what jlink does. So jlink allows you to say, here's the modules I need for my application. Build me a runtime that I can ship with that for my application. If we look at the example here, it's a very simple example. I've got a simple application that is modularized. And if I say to jlink, here's where to find the modules, here's the module which contains my main entry point, and here's where I want the output to go, jlink will then determine all of the relationships between the modules that are required for that application. I don't have to do it explicitly. And then it will build a directory structure which looks just like the JDK. But it only contains the modules I need for my application. So if I go into my image in the bin directory and I run the Java executable in that, what I'll find if I use the list modules command line flag is I get Java base, Java logging, Java SQL, XML, and then 3 modules for my application, so Zap, Zoop, and Zeta. So that's good, you see, because now we've got a much smaller runtime, and for things like containers, for things like microservices, this is really good, because you build your runtime, put it in your container image, and then ship that. So this is a very good way of using modules. You can also use it for applications which still run on the class path. So you don't have to use an application that has been fully modularized. You can run it with the class path. I'll go back. So in order to do that, you can use the JDEPS command. And JDEPS will analyze the dependencies for you and list out all the things that you need. OK. So now, the other thing that happened when JDK 9 came out was that Oracle decided that they wanted to change the way that they develop and deliver Java. And they came up with this catchy phrase, moving Java forward faster. What does that actually mean? Well, I'm sure most of you are probably aware of some of these things, but let's talk a bit about what's really changing with the JDK. First of these is that Oracle wanted to use a new release model. Rather than having the way of delivering Java as it has been for the last, well, 20 years, where we've had major releases which have taken years to come out with a new release, what they said is, OK, we're going to come out with a new release every 6 months. So 2 releases a year, every year. And we've already seen this because JDK 9 came out in September of last year. JDK 10 came out in March this year. JDK 11 came out just 2 months ago. So it's already starting to work. The reason for this was because they wanted to be more in step with the way that people develop software these days. We've moved away from the old-fashioned waterfall approach, where you gather all your requirements, you do all your design, you do all your development, you do all your testing, and then you deliver your application. It's much more the case that we're using an agile methodology now. So much more iterative, much more adapting to changing requirements, the ability to pull these requirements in, make changes on the fly, and get things out with releases much more frequently. So that's what they wanted to do. They wanted to be more agile with the development of the JDK. Rather than having a target which was 2 years between major releases, which they never actually managed to do, they would have a release every 6 months. Now, in order to do that, they needed to change the way they added features to the JDK. In the past, JDK development was driven by the features. When they started developing a new JDK, they would select a number of features for that release, and then they would build that feature, develop it, and only when they were ready would the JDK ship. If we look at JDK 9, that's a good example. We had modularity. Modularity was the key feature in that, and because it needed to go through a number of revisions, and there were some issues that needed to be resolved, it delayed the release on at least 2 occasions. It might have even been 3. So that wasn't going to work. What they decided to do instead was to kind of turn that around and say, rather than deciding on features for a particular release would have whatever features were ready at that time. That way, if you had a feature that you thought was going to go into JDK 12 and it wasn't quite ready at the point where they needed to do the feature freeze, then they would say, okay, well, let's just delay it to JDK 13. It's only 6 months away. People are not going to be too concerned if they have to wait a bit longer for that feature. But it doesn't delay the release of that particular version. So that's all a good idea. It means that we get new features more quickly, much more agile. I like it. It's a good idea. The next thing that Oracle said was, because of the faster release cadence of the JDK, it wasn't going to be practical to have long-term support for all of these releases. If you've got a release every 6 months, after sort of 3 or 4 years, you're going to have lots of different versions, and trying to provide updates to all of those is really going to be just too much work. What Oracle decided to do instead was to follow the sort of example that's been set by people like Ubuntu. What you do is you say, okay, we'll select certain releases as being long-term support ones. That's not every release. We'll have, in the case of Java, we'll have 1 every 3 years. The ones in between that will be feature releases. So they will have updates until the next version comes out, and then long-term support can be provided in a different way. To get things started, JDK 8 was classified as a long-term support release, and Oracle decided that they would extend the support of JDK 8 until January of next year. And in fact, that's only for commercial users. So commercial users, anybody deploying JDK 8 in a data center or in a commercial organization on desktops, will only get updates until January of next year. If you're sitting at home and you're playing Minecraft, then you'll still get updates until the end of 2020. So that's JDK 8. JDK 11, the one that just came out, is the first new long-term support release under this new release cadence. So JDK 9, JDK 10 are both feature releases. And that means that they only get updates until the next release comes out. So only 6 months of updates, and then that's it. If you look at JDK 9 and JDK 10, there is no more development of that at all. Now, the next question is which JDK binary to use. In the past, that's been a very simple decision for most people. If you wanted Java, you would go to java.oracle.com, or in the old days, java.sun.com, and you would select the particular version of the Java that you wanted, you would select which particular platform you wanted it for, and then there'd be a little checkbox next to that, which would say, I agree to the terms of the Oracle Binary Code License for java.se. So you tick on that box, got no idea what's actually in that license, but you tick on the box anyway. Now, I do know there's a couple of things in there, one of which is called the field of use restriction. And the field of use restriction says that if you want to use the Java for a desktop, If you want to use it on a server, then it's completely free. If you wanted to use it in an embedded device, if you wanted to use it on a single-purpose machine, like a kiosk or a ticket machine, something like that, even though it might have a PC in it, you need to license it separately from Oracle and negotiate whatever terms they want. So free use of Java if you're on a desktop or you're on a server. What Oracle have now done is to create a second binary. So the first one's the Oracle JDK binary. The second one is the Oracle OpenJDK binary. This is available through jdk.java.net, and that has a different license. So this is now licensed through the GPL version 2 with class path exception license. That's a less restrictive license, so if you do want to use it in embedded devices or single-purpose devices, then there's no restriction. The thing about these is there is no concept of long-term support. The Oracle OpenJDK binaries only have updates for 6 months until the next release comes out. That's essentially 2 scheduled updates. The other thing that's important is there's no overlap of updates. So because you only get 6 months of updates, no overlap with the next one, no time to migrate by making changes and so on. Now, this led Oracle to decide to converge these 2 binaries. And if you look at what the Oracle JDK binary contains in terms of like a Venn diagram, JDK 10 and earlier is what I've drawn here. So the smallest part of it is the java.se specification. That's the core libraries, that's the compiler, that's the virtual machine, all of the things you need in order to call your product Java. OpenJDK is the source code reference implementation for java.se. So you would expect those 2 circles to be the same, but they're not. OpenJDK is actually a superset of java.se. The most obvious thing that's in OpenJDK that's not in java.se is the Nashorn scripting engine. So that's in OpenJDK project, but it's not covered by the standard. Oracle JDK is then a superset of the OpenJDK, and they ship a number of extra features that are typically commercial features to make the Oracle JDK better than just what you get in the OpenJDK. With JDK 11 and onwards, our diagram changes slightly. So what Oracle have done is they've said, let's eliminate any functional differences between the Oracle JDK and a JDK that you build from OpenJDK source. So Oracle have got 2 different binaries. The idea now is that functionally, they are exactly the same. So there's no extra features in the Oracle JDK. It's exactly the same as what you get with the OpenJDK. How they did that was in 2 parts. The first was that they contributed a number of what had previously been closed source commercial features to the OpenJDK project. The most obvious of those are the flight recorder and mission control tools. So these are used to monitor your JVM to see what's actually going on with your application and see how it's working. They've been very popular, and now they are open source, so you can use them for free with no licensing restrictions. There's a few other things like application class data sharing, which gives you more advantages in terms of resource utilization and startup time and so on. The other thing they did with JDK 11, with the Oracle JDK, was to remove other closed source parts. The notable ones about those were the browser plugin. So now there's no more support for applets in JDK 11. Anybody here using applets? Ooh, a couple of people. OK, right. Java Web Start also goes. Anybody here using Java Web Start? OK, just a couple of people, yeah. And JavaFX. Now, JavaFX has never been part of the standard. And the good news is that JavaFX is a separate open source project under the OpenJDK. There's a nice company called Gluon who provide binaries of that for free. So if you are using JavaFX, it's very easy to just download the necessary parts to make that run with JDK 11. So let's talk about compatibility, because this is a big thing. Now, with the change to modularity and some of the other changes that Oracle have made in terms of the JDK, we need to consider how the compatibility works in terms of moving an older application to the newer platform. And this is what Oracle's product management say. They say clean applications that just depend on java.se should just work. It's a little less than reassuring. I personally would like to see it will just work, but no, it should just work. And so there are they've been quite precise in the language that they've used, which we'll see a little bit later on. So one of the reasons for this is that JDK 9 started something which was long overdue in Java. For 20 plus years, things have been added to Java to make it better. You know, added new features, new libraries, new classes, and so on. And that's all very good. But the problem is that nothing has ever been removed from Java. So we've kind of ended up with this 20 years of lots and lots of good stuff and stuff that's kind of got really kind of crusty and old and really isn't being used by many people, if anybody. So the developers said, right, JDK 9, we're moving to modules. We know we're going to have to, cause some problems for people moving to JDK 9. So let's not actually make them worse, but let's at least kind of put all the pain in one place. So what they said was, right, over time, we have deprecated many APIs. In fact, there's about 450 deprecated elements in JDK 8. And so they said, in JDK 9, we will finally remove some of those elements. And that's what they did. They removed one class, which actually wasn't even part of the standard. That was in the Java Authentication and Authorization Service. And they removed 6 whole methods. That was it, 6 methods. And you look at that and you go, well, what did those 6 methods do that was so bad that meant they were the ones that got removed? And essentially what it was to do with when they had to separate out the modules, they found there were some very odd relationships between different parts of the APIs. And so by removing those 6 methods, it actually simplified a lot of places where they needed to kind of separate out the modules. JDK 10 took that a little bit further, so they removed a whole package, 6 classes, 9 methods in 1 field. They also removed some other redundant features, so things like the JHat tool went away, the JVM tools interface, hprof agent went away, and there were a number of garbage collection options, things like incremental concurrent mark sweep, using the parallel new collector with the serial old collector. These all just disappeared. They've been deprecated in the past, so you would have had warning, but they've disappeared in JDK 9. JDK 10, JDK 11 continue this work. There's other things that have been removed in those as well. And this is not going to finish. This is not the end of it. There's going to be more things that are likely to be removed. So if you look at what's been deprecated at the moment, CMS is deprecated. So at some point in the future, you may well lose CMS. The idea is that G1 is a replacement for that. Oracle don't want to have to maintain 2 very similar garbage collectors. Nashorn has been deprecated. So if you're using JavaScript via the Nashorn engine, then you may need to think about that at some point in the future. Pack 200, all deprecated. So the key thing here is that compatibility is not guaranteed. And Oracle, again, have been quite specific about this, and they've said that new versions of Java may include breaking changes. They have also said that they'll be very nice about this, and they will give us warning. So they will deprecate anything that's going to be removed before they remove it. And they will give us a minimum of 1 release warning. Well, that's good, because if they gave us less, that would be no warning at all. But it means that it could be only 6 months between something being deprecated and something being removed from the JDK. Something to bear in mind. Right, so let's eliminate some confusion, or try to eliminate some confusion. Because I've spoken to a lot of audiences about this, and lots of people have seen all the announcements that Oracle have made, but sometimes they've interpreted things in a slightly different way to what reality actually is. So the first thing is that Oracle has said there will be a long-term support release every 3 years. Okay, that's clear, nothing difficult to understand about that. But what that does not mean is that there will be 3 years of free updates. So even though there's a new long-term support release every 3 years, we're not getting 3 years of updates between them. The other thing that changed with JDK 11 was the license under which the Oracle JDK is released. In the past, it was the Oracle Binary Code License of java.se. Now it's the Oracle Technology Network License Agreement. And what that says is that you can download the Oracle JDK, you can use it for development, you can use it for testing, you can use it for demonstrations without charge. If you want to put it into production, then you will need a java.se subscription. And that's a cost option that you will need to pay for. So JDK 11, the Oracle JDK, is no longer free for use in production. If you want to use JDK 11 from Oracle for free, then you will need to use the OpenJDK binary that they have created. So go to jdk.java.net, and you could download the free binary for JDK 11, and then you'll be able to download free binaries for JDK 12, and so on. The thing about that is that if you remember, I said that there's only 6 months of updates to the Oracle OpenJDK binary. There is no long-term support release in terms of those binaries. That means if you want to continue using the Oracle JDK for free, then you will need to update your JDK every 6 months. That's quite a significant thing. Certainly if you talk to a lot of people, a lot of customers, trying to change JDK every 6 months is just not achievable. The other thing that people get confused about is JDK 8. JDK 8, the license hasn't changed. It means that you can use JDK 8 indefinitely for free. There's no problem with that. But bear in mind that as of January next year, when the last public update comes out, then you can carry on using JDK 8 without any problem, without paying any money, but you won't be getting any more updates for commercial use. So, what happened in JDK 10? What did we get in JDK 10? Right. Well, we only had 6 months of development, so the number of features obviously drops down a bit. Most significant of these is local variable type inference. So in JDK 10, Java gets var. Wonderful. Now we're a bit more like JavaScript. Is that a good idea? Anyway, so now what you can do is you can say, rather than explicitly stating the type of a local variable, you can have the compiler infer it for you. In these simple examples here, you can say, okay, var list equals new array list of type string, and the compiler will logically infer from that that the list is an array list of type string. Similarly, if you use the stream method on that list and retrieve a variable and call it stream, the compiler will infer from that that the type is a stream of type string. Now, there are certain things you can't do. So, for example, you can't do var x equals null. That won't work because the compiler will complain about that and you can't do it. There are some good uses of var. So something like this, where you say var string list, nice, useful name, is a list of ABC. So that makes sense. It's easy to see what type of variable you're probably using there. You've got a list of strings. Great. There are some situations that might catch you out a bit, so you need to be careful. So, for example, in this case, we're using type inference for the local variable, but we're also using the diamond operator to have the compiler infer the generic type parameter for us as well. Because we don't actually provide any information about that, the compiler will infer correctly for us that our priority queue is going to be a priority queue of object. So nothing wrong with that. It's perfectly valid code. It will work. But just be aware that if you do use the diamond operator, you're going to get an object rather than something else. Other things that went into JDK 10. Most of these are things that you won't really see much effect, certainly from a development point of view. Some of them are more for deployment, but there are things also in terms of changing the JDK and the JVM. So they added a parallel phase to the full GC for G1. One of the things that they found was that the rate at which the G1 collector was generating throughput wasn't as good as the parallel collector, and that was because the full compaction was serial rather than parallel, so they've changed that. Application class data sharing I mentioned briefly as one of the features that was contributed from closed source to open source. And this is a nice idea because when you start up your JVM with your application, JVM has to read all the class files that are required for the application, and it has to generate some internal data structures. Every time you start your application, it has to do the same thing. What application class data sharing allows you to do is to start your application up and then record a file which is, in essence, a copy of the internal data structures in an external file. Then when you start up the JVM again, rather than having to read the class files and process them, the JVM can simply map that file into memory and make use of the data structures that are already there. Similarly, if you've got multiple JVMs running the same application, they can all share that file through memory mapping, and it reduces the amount of resources you need for running those multiple applications. There is an experimental Java-based JIT compiler called Graal. This is part of a bigger project looking at how to replace the entire JVM with one written in Java rather than written in C++. Root certificates, this is really tidying up some of the differences between the Oracle JDK and OpenJDK. So the root certificate CA certs file is now populated in OpenJDK, whereas before it was empty. And they've also tidied up some of the source code by consolidating 8 repos that made up the JDK into a single repo. Other things, heap allocation on alternate devices. This was contributed by Intel. This allows you to put your heap not just on DRAM, but you can also put it onto non-volatile RAM, because there's some of the Intel non-volatile RAM which will perform as well as DRAM. So now you can either put it on non-volatile RAM or on DRAM. Java H tool has gone away. That's been replaced by a -H option on Java C, so it does the same thing. Garbage collector interface was provided by Red Hat, and that's for the internal JVM interface, not from the application code to the garbage collector. Because Red Hat are working on their Shenandoah garbage collector, they wanted to tidy up the way that you could insert a new garbage collector into the JVM, and so they did that work to make it easier to change the garbage collector. It helps us at Azul because we have our C4 collector that we use in Zing. Thread local handshakes was just a very low-level thing in terms of improving efficiency for pausing a single thread and not having to reach a global safe point in order to do so. JDK 10 included 73 new APIs. I picked a few of the ones which seemed more useful. So there's now new methods on the collections API, so list, set, and map all have a copy of method, which will take a collection and return you an unmodifiable version of that collection. Related to that, the streams API has collectors, which will now take the output stream and generate an unmodifiable list, map, or set as a result. And then the optional class also gets a new method called or-else-throw, which is basically the same as get, but that's what they just decided to add a method. JDK 11, right, what do we get in JDK 11? Again, 6 months of development, so not too much in terms of new features. A steady pace, we should say. So there were 17 JEPS, JDK enhancement proposals, that were included in JDK 11. And what we're seeing now is more input from outside of Oracle. This is very good. So this started off in JDK 9, where Azul were the first company to actually have a JEP accepted and integrated into the JDK. JDK 10, we got a couple. JDK 11, we've had 3. So the first of those is the Epsilon garbage collector, which again came from Red Hat. Interesting idea, the Epsilon garbage collector. Epsilon garbage collector doesn't collect any garbage. So you think to yourself, what's the purpose of that? And there's actually 2 things you can do with it. One, which is what it's really designed for, is to evaluate the performance of a garbage collector. So the idea is you run your application with the Epsilon garbage collector, so it's not doing any collection. You see how well it performs. Then you put your new garbage collector in, and you see how well it performs with that. And you can see the difference between the 2. Some people are also saying that they can use it in real-world applications, where if you've got very short-lived applications that aren't going to run out of heap space, then it might improve performance. It's a little bit risky, but, you know, best of luck on that one. Another one from Red Hat was improving intrinsics for the ARM64 architecture, so they've contributed some more code there. And interestingly, Google contributed a JEP to JDK 11, which was for low overhead heap profiling. In terms of language changes at JDK 11, very small. Local variable syntax has now been extended to lambda parameters. What does that mean? Well, what we could have is something like this. So we've got a stream, and within our stream, we've got a lambda expression. So we're mapping from a string to the lowercase version of that string. Okay, that's all good. Now we can use var, like that. And you look at that and you go, why? Why would I want to do that? I already have type inference in a lambda expression, so I can say s. I don't have to say string s. So you want me to add var to that with brackets. Why would I do that? And the answer is one situation and one situation only, which is where you would use an annotation. So if you want to use an annotation, you can't use an annotation without a type. So the syntax simply has to be, you could put not null string s, or to make it simpler, you can use var now. So it's just a very small kind of corner case where they've extended the use of local variable syntax. One of the things I always like looking at with Java is how Unicode changes, because this is the thing that gets updated when we update the JDK. And in Unicode 10, which is included in JDK 11, they found 8,500 new characters. And you look at that and you go, 8,500? Where did they find 8,500 new characters? So I thought, right, I'm going to find out. Well, one of them's the Bitcoin symbol. So great, we've now got Bitcoin symbol. Then we have a thing called Nishu. Anybody know what Nishu is? No, I thought not. Nishu is a character set which is used by Chinese women to write poetry. That's why I guess nobody was going to know that. And then we have Soyombo and Zanabazar Square, which are both character sets used by Tibetan monks to write prayers. It's good to know. And then finally, we have the apparently long-awaited Colbert emoji. Now, the nice thing about this is in JDK 9, they modified property files so you could use Unicode, which means that you can use Nishu, Soyombo, and the Colbert emoji in your property files, if you want to. Another thing in JDK 11, which is a nice feature, remains to be seen how much it actually gets used, is launching a single file source code. If you look at JDK 10, there are 3 modes where you can start off a Java application. So the first of those is you simply launch a class file. So Java, main, and that will launch from a class file. Second is you can launch from a jar file, so you can do java -jar main.jar and launch from that. And you can do it from a module, so you can do java -m main.module or main.jmod or whatever. JDK 11 introduces a 4th way of doing that, which is to launch a class declared in a source file. So rather than having to compile your Java file, you can simply say java factorial.java 4. The Java launcher will then look at that and say, that is not a set of bytecodes, it is Java code. I will run the compiler on it, generate a class file, and then execute that class file with the parameters that you pass to it. So that's all very nice, but you can go one step further because you can use Shebang. And you can actually create a file which allows you to do sort of kind of scripting with Java. So the first line has your shebang with the where to find the Java, and then you use -source11 to indicate which source level you want to run with, and then you specify the code for your single file application. Then, if that's made executable, you can simply do /factorial4, and you get the result because the compiler, the Java runtime will look at that and go, right, I need to compile it, I then need to run that class file. The primary reason really for doing this is to make it easier to get started with Java, so we can get more people to write Java. Lots of other JDK JEPS that went into JDK 11. I'm not going to go through all these in detail. Nest-based access control is to do with inner classes and how you can reference a private variable from the surrounding class and what the JDK and the JVM actually does in terms of making that accessible. This is related to Project Valhalla and the idea of value types, which I'll talk about in a few moments. Dynamic class file constants is extending the class file constant pool so that, in effect, what it's allowing you to do is to have a final variable in the constant pool, which means that you can set the variable once, but then it's fixed. The reason for doing this is that it helps people who are writing languages that are not Java to be compiled into bytecodes, and people writing compilers to do that. So there's a number of reasons to improve the efficiency of non-Java languages running on top of the JVM. The HTTP client, this is HTTP 2. It was released in JDK 9 as an incubator module with the idea that people could try it out and suggest changes to make it even better. Once those changes were confirmed, then it would be made part of the standard. So this is now part of the standard in JDK 11. There are a number of things around elliptic curve cryptography and using different algorithms to do various different things. So if you want to find out more about those, I suggest you read the JEPS on those. Transport layer security 1.3, that's good, helps to avoid some of the problems. ZGC is an experimental low latency collector. It is still very much experimental. People I've spoken to have said, yep, it's got some interesting results, but it does tend to crash a lot. Nashorn, PAC 200, as I said, have been deprecated in JDK 11, so at some point they will be removed. New APIs that we find in JDK 11. So there's some interesting ones here. So you now have the ability to get a null input stream and a null output stream. That's one that you can read precisely 0 characters from, and you can throw as many characters to as you like, and it will do nothing with them. So it's kind of like /dev/null. And I looked at that, and I thought to myself, why? Why would you want that? But there are some very good situations where that makes sense, and especially if you're using streams and you're doing some sort of functional style of programming where you need an input stream or an output stream, but you don't actually want to do anything with it. So there are logical places where that would be useful. Optional now has isEmpty, which is the opposite, logically, of isPresent. And character has a new toString method, which takes an int, which is a Unicode code point. String has been shown some love and now has some new methods. So there is an isBlank method, which will, well, funny enough, tell you if it's a blank string or not. There's a lines method that will give you the ability to turn a multi-line, or if you've got code line breaks in your string, then it will give you a stream of the individual strings that are separated by those line breaks. Then there's repeat, which will repeat the string a number of times, and then you've got strip, strip leading, and strip trailing, which will remove white space from either both ends, the preceding or trailing end. Logical thing there as well, what's the difference between strip and trim? And the answer is how you treat white space, because it uses a different definition of white space between trim and strip. Go and have a look at it if you want to figure out which one you should be using. Probably my favorite feature in JDK 11 is the not static method that's been added to the predicate. And what that allows you to do is to invert a predicate, funnily enough. So we might have a situation like this where we're doing a filter, and our lambda expression is that we're taking strings, and we want any string that is not blank. So we use bang s is blank. We can rewrite that with the not method, and we can say filter predicate.notString : is blank, use the method reference, and it looks a bit nicer. But if we use a static import, we could actually make it even nicer, and we can say filter not string is blank. And it's more readable, so that's good. JDK 11 removed some modules. These were deprecated in JDK 9 and weren't included by default for either compilation or runtime. Now they have actually been removed completely. So if you're using Corba, if you're using JAX-B, if you're using JAX-WS in any way, shape, or form, then these are not supported in JDK 11 anymore. So this is the java.se.ce aggregator module. That has completely gone from JDK 11. Command line flags, again, something I always like to have a look at. So JDK 9 removed 187 -XX command line flags, which makes you realize if they removed 187, how many were there to start with? And the answer is about 750. So they then added another 123, so they didn't really move a whole 187. JDK 10 removed 36, added 26. JDK 11 removed 27, added 53. Chris, who codes, has got a lovely website or web page which gives you all sorts of detail about this, so it's well worth having a look at that if you want more information. So longer term JDK futures, just quickly go through some of these ideas. Project Amber is about simplifying the syntax of Java. And if you look at the popularity of languages like Kotlin, it's because it has less verbosity in the syntax. So they're doing a number of things with that. One is simple changes like the ability to use a single underscore as a parameter in a lambda expression. So if the parameter is not used in the body of the lambda expression, you can sort of hide it to make it obvious that it's not being used. Raw string literals are already in JDK 12. This is the idea that if you want to have multi-line strings, or if you want to have odd characters in your string, then you can use a backquote to indicate that everything after that backquote until the next backquote is a string. And that means if you go across multiple lines, it will work. If you do things like backslash, that will work without having to escape it. Of course, the logical question then is, well, what if I want a backquote in my string? And the answer is, well, they've thought of that, which means that you can use one or more backquotes. So you could have backquote, 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 a string with two backquotes in it, backquote, backquote, backquote. Right. Pattern matching. Some of the ideas they have with Project Amber is to improve the way that the switch statement works. So if you look at the switch statement at the moment, you can switch on a value. You can switch on an integer, you can switch on a string, you can switch on an enumeration. Now, with pattern matching, if and when it's included, you'll be able to switch on a type as well. So rather than having to have a long, complex if-else using instance of integer, instance of byte, and so on, you can simply say case integer I, case byte B, and then specify in the body of the case what you actually want to do with that. So it's just extending it so that you can use a type rather than a value. The more interesting thing is around switch expressions, because this is a very common pattern for using a switch statement, which is that you switch on one value, and then you want to assign something to another value based on that. So here's an example where we're taking days of the week, and we're switching on a day, and then we want to assign the number of characters in the name of the day to a value. So num letters equals 6, 7, and so on. Very verbose, lots of lines of code, plenty of opportunity to make mistakes in there. So what we do now with JDK, and this is in JDK 12 as well, is simplify that a lot. What we say now is that we can actually have the switch statement return a value, and then we just make one assignment. Num letters equals whatever the switch statement returns. Then they've finally cottoned on to the idea that you could have a comma-separated list of things that you want to switch in your case statement, rather than having to individual case lines. And then we'll steal some of the, or borrow some of the syntax from the lambda expression and say that we'll use the arrow, and then whatever's on the right hand is what's returned by the switch statement. And obviously, we also need the ability to throw an exception if something is something we don't want. Project Valhalla is the idea of looking at how to rationalize some of the performance that we get in terms of storage for Java. When Java was first created, we had the idea of primitives and objects. Primitives were there for performance. Objects gives us all the things like encapsulation, polymorphism, inheritance, and so on. But we have situations where we can't use them both. So for example, we can't do an array list of int. We have to do an array list of integer, and there's a whole lot of extra stuff that goes on in terms of boxing and unboxing, garbage collection, and so on, and things like that. So Project Valhalla, one of the things they want to do is to enable you to do an array list of int and have it stored as ints rather than integers. The other thing is value types, which is where we're creating a truly final value. Because if you have a final value in your class at the moment, you might think it's final, but with reflection, you can actually change it. So with value types, by fixing the value and making sure it cannot possibly be changed, then we have something that codes like a class, but works like a primitive. Project Loom is about concurrent programming. And if you want to scale up to tens of thousands, millions of threads, that doesn't work by mapping each Java thread to an operating system thread. It's too heavyweight. So what Project Loom is going to do is give you fibers. Fibers is where you have multiple fibers mapping to a single operating system thread, and the JVM will be responsible for scheduling those fibers on that thread. By doing that, it doesn't require too much work in terms of changing Java, because they're going to use the fork join pool scheduler that's already there. They essentially need to add continuations, which is a flow of control for a given thread. And then by doing that and having the JVM switch the threads or the fibers individually, it's much less memory usage and very close to zero overhead in terms of task switching. Just briefly mention Azul's Zulu Java, since I've got about a minute left. This is our free version of the OpenJDK. So we build the OpenJDK source code, we create a binary for that, we run the TCK on it, we pass all the tests, make sure it conforms to Java. We support older versions, so we go all the way back to JDK 6. We have 7, 8, 9, 10, and 11. And we also have wider platform support. So in addition to the 64-bit versions, we also have 32-bit Windows and Linux. That's JDK 8 and 9, 10 at the moment. 11, we're still working on for that. ARM32, ARM64, PowerPC, if you're interested in embedded support. As I say, you can go to our website there. You can download that, use it for free. If you're interested in a commercial support contract, we will talk to you about that at a very reasonable price. Oh yes, and I've been told to, there we go, I've been told to by Bruno to put this slide in so that, to mention that we actually have Zulu being used on Microsoft Azure. So you get free support. If you're using Microsoft Azure, you will get free updates to the Java that you use on there. And with that, just to summarize, like I say, Java continues to evolve. Faster release cycle, access to updates is going to be a consideration as you move to newer versions. Lots of ideas to improve Java, as we've seen, things like value types, fibers, and so on. And if you're interested in an alternative JDK distribution, then Zulu is the one to look at. And with that, thank you very much.